Hey there, welcome to my first science video. My name is Michael Perez, and I will be posting regularly really cool science-related material, from the really big astrophysics to the really small quantum mechanics. Feel free to leave recommendations in the comment section for topics that you prefer, and hopefully I'll decide to cover them. My first topic of choice is the Fermi Paradox, or at least propositions or solutions to the Fermi Paradox. Enrico Fermi, a physicist, a mathematician, a Nobel Prize winner, was once having a lunch with his colleagues and asked a very simple question. All the science is pointing in one direction, that this universe should be teeming and exploding with life. If that's the case, how come we haven't encountered any life? Where are all the signs? And that's the Fermi Paradox. Humans tend to make the arrogant assumption to believe that we are unique or the center of the universe, when in fact we are comprised of the most common elements found in the universe. Furthermore, for a very long time we thought that our world was the only world, until shortly after did we notice that we have neighboring planets, and that we exist within the confines of a system, namely a solar system. And shortly after that we discovered that there are many solar systems and we live in a galaxy, a single galaxy. Shortly after that, we realized that, hey, there are many galaxies and we exist within a single universe. And now there are many independent fields in science which are converging to the notion that we exist within a multiverse and that there are many universes, and who knows where the logic takes us from there. The point is, we're likely not that special, and there is never one of anything. If we are capable of looking up into the stars and saying, are we alone? Likely we're not the only ones asking that question. We exist in a vast universe and in an ocean of probability. And Murphy's Law is surely expressed. What can happen will happen, no matter how unlikely it is. Biological systems are chaotic and heavily influenced by their initial conditions. A slight change in your initial conditions, or the environment in which life forms from, can have a profound implication on the outcome, or what life might actually be. That being said, you can have planets with slightly different properties than ours, and that can yield completely different forms of life. Never mind the planets that have completely different properties. It is inconceivable what the results could be. We have absolutely no idea how abstract the definition of life should be. This may seem like a strange assumption, but it holds a lot of weight. You can have life form through silicon and not carbon, or you can have life structure without DNA. This is very hard for us to understand because we've only experienced life here on Earth. This process is impossible to understand on a universal scale. There are too many unknown life-based variables to account for. However, the following example can provide some insight. We humans are acting as a transfer medium, passing the baton of life from biological systems to technological systems. And this process will surely expedite once we develop a comprehensive model of the brain. So I have a question for you. Technological systems, such as robots, will soon have the ability to self-educate, self-repair, and make like their own, procreate. In fact, this may sound quite strange, but the offspring of robots will no longer be bound by Darwinian constraints, but rather by the exponential rate of growth described by Moore's law. In any regard, here's my question. When that day does come to fruition, will these robots be considered alive? If so, where do we draw the line for life? By any conventional tools used today to measure life, they would fail. The point and problem here is, we need to define what something is before we quantify what it is or isn't. And given that our sample space of life is 1, us, it doesn't really yield a very accurate description. So, it's absolutely imperative that we don't allow our only experience of life on Earth affect our ability to imagine how life can exist in space. We tend to think that life on other planets, or potential life on other planets, will think like we do, will have the same ambitions that we have, will have the same sociological constructs that we have. Likely none of those are correct. And this is very hard to understand how highly intelligent beings that can exist on other stars or planets will think. And A way to understand that would be to way to understand the limitations an ant or a creature would have relative to us. We study calculus, we study mathematics, we study computer science, we study all sorts of amazing things that we have achieved, but yet if I were to try to teach calculus to an ant, that would be a futile pursuit. It has no idea what I'll be talking about. All that concerns the ant is collecting food for the queen or whatever they do. So the point is here, if we want to create some framework for understanding, it's imperative that we don't impose our rationale and way of thinking on them. Alright, my first proposed solution is something called the Great Filter, which states that civilizations don't last very long. There are certain hurdles in which they have a very, very, very hard time passing. With respect to us, that has three implications. Either we are very rare, we are the first, or we're screwed. Starting with the latter implication, that we are screwed. Sounds depressing, but can certainly harbor truth. It's very possible that we have yet to encounter our great filter. And it's very possible that that filter can even lie 1 million or 2 million years ahead, which is still very insignificant relative to the existence of the universe. Civilizations can live for 2 or 3 million years longer than us, but we still look into the sky and we would see nothing. One would be a technological filter. It could be that the gap period between us creating tools that can destroy ourselves and having the ability to colonize interstellar space is too vast. So we end up destroying ourselves before we could spread out. An example, Einstein discovered the power of the nucleus. That yielded nuclear weapons. We have nuclear weapons today, and it doesn't take much to create a nuclear apocalypse, but we are very, very far from being able to travel interstellar space. We have many, many hurdles we have yet to even discuss or think about before we consider that a serious prospect. And we could be talking 1,000 or 2,000 years. And within that time frame, it can be very likely that we will eventually encounter a nuclear war, which will ensure our own destruction. Don't focus on specifics, but that example could demonstrate how there are certain hurdles in which civilizations have a very hard time surpassing. And the first 2 points were either that we are rare or we are the first, and both of those hold really good news, and what they imply is that we have passed this great filter. And for this reason, when we look into space, we don't see other civilizations. They're either really, really, really far away, or they're just not there. I personally don't subscribe to this notion because Earth itself came to existence very late in the existence of the universe. When it did have the conditions to harbor life, life spawned immediately. This kind of gives me the feeling that life is more common than it should be, and I also subscribe to the notion that we're not as special as we think we are. An example could be abiogenesis, right? Non-living matter to living matter. The conditions need to be so perfect, and the mixtures and the chemistry and the geological structures need to be so in tune for this process to occur. And it could be we really just hit it lucky, and so lucky that it doesn't exist anywhere else. Another example can be photosynthesis. The process of converting sunlight into useful energy on our planet is extremely rare for it to even occur. Or the environment for photosynthesis is extremely rare. For example, if our magnetic field was too strong, not enough energy would seep through it. Or if our magnetic field was just a little bit too weak, anything that would occur would just be bombarded by radiation. Proposition number 2, that spatial civilizations just don't care about colonizing the universe. It's not a priority for them. Maybe beings that are way more intelligent than us don't have any interest in those kind of pursuits. And it could be that creating a virtual utopia for them to exist within, where they're happy and on vacation all the time, is the life, and finding resources on other planets are just not a necessity. Proposition number 3. Spatial civilizations have incentive to remain quiet. This proposition holds a lot of weight, as it is consistent with Darwinian traits. A zebra will not run into the open area in the middle of the night screaming, "I am here, I am vulnerable to anyone who wants to eat me." Makes no sense. There's no advantage. There is advantage to remain quiet. And that is perhaps why civilizations remain quiet, because it could be that there are other predatorial civilizations looking to hunt and steal resources of anyone who's available. Famous physicist Stephen Hawking was once asked if we should broadcast our location into space so that spatial civilizations can know where we are. He responded, and I quote, "If aliens visit us, the outcome would be much as when Columbus landed in America, which didn't turn out too well for the Native Americans." Time and space are significant, and we have not obtained enough information to make a coherent conclusion. It's like going to your backyard and looking for 3 or 4 minutes and for deers, and you don't see any. So your conclusion is there are no deers in California. It's erroneous to make that assumption. You have not looked far enough and you have not looked long enough. So to here, when we look into space, we've only been intercepting radio waves for a measly 60 years. That is insignificant. Also, we've only been looking at a distance of 60 light years, which is just as insignificant. We have not obtained enough information to know whether life exists on other planets. Proposition number 5. We are so insignificantly sophisticated that we're just not interesting. When you're driving on a highway, you don't pull over to look at a pile of ants in the corner. It just makes no sense. Perhaps that the universe is full of life and they see civilizations all the time. So until we make ourselves relevant, they have no reason to come visit us. Proposition number, I can't do it, but 6. Our mediums for communication are just incompatible. 100 years is insignificant relative to the existence of our universe. Just 100 years ago, we had no clue how to use radio signals. There could be species out there that are literally millions of years more advanced than us, and they could be using mediums that we have not yet achieved. It's kind of akin to when we were in preschool or elementary school and we were using those walkie-talkies, and we would call out on the walkie-talkie if anyone is there and no one would respond. And having the conclusion that there's no one that exists in our vicinity is erroneous. It's very likely that the person right behind us was using their cell phone and we just didn't have the right way of communicating with them. It's the same relevance here, where these species could be using forms of communication that are way more sophisticated than us. So in conclusion, I believe that life is tenacious and relentless. If you were to look at any location on this planet Earth, no matter what the conditions are, you will find that there is a friendly sign of life everywhere. And I think that logic applies to the vastness of the solar system and the vastness of the universe as well. I do believe that in my lifetime we will find either fossilized microbial life or living microbial life, and I think that will force us to redefine the philosophy of our own existence. Thank you so much for watching my first video, and don't forget to subscribe because I will be posting a lot more. And you can leave recommendations for other topics as well. Thank you.